Amazing people, what we're going to do today is we're going to look at exponential functions. Now, these particularly are functions which are of the form where we've got y equals a to the x. Now, specifically, what this is we've got a variable where it's located in the indice of a constant variable, with a being a constant in this case. Now, there's a couple of things we need to know about these functions. The first of all is let's consider what the domain is of this function. Now, the domain is the possible x values that it can take. Now, in this case here, the values it can take are between minus infinity and infinity. And so what we would say is there is no restriction on the domain in this regard. Now, in particular with this, it never actually reaches infinity or negative infinity. So that's why we keep the curved brackets around it here. Now, also, what I'd like us to consider is the range. Now, with the range of one of these graphs, that's the possible y values. Generally, what it's going to have values from 0 up to infinity. And the reason for this is it's not going to produce any values of 0 because when you have a number to the power of 0, the answer is 1. And you can get that smaller and smaller, but it's never actually going to be 0. So again, it's not quite approaching this. So in this case, the range is restricted to being above the x-axis. Now, as a result of this, one of the things we have to take into account is the x-axis is then going to be an asymptote. Now, an asymptote is points where a graph approaches but never actually touches. So we'll get ever so closer, but never actually reach that point here. Now, in addition to this, one of the form of y equals a to the x, it's always going to have a y-intercept, but it's always going to be 1. Now, the reason for this is if we have any number that a may take to the power of 0, that is always going to be equal to 1. So that's why the y-asymptote is going to be 1. Now, a couple of other things to consider if we have the values of x. So in this case, we want to consider values of x which are less than 0. When we consider that, what's going to happen is then y is going to produce some values which are between 0 and 1 when x is less than 0. Now, if we consider values of x which are greater than 0, what this is going to mean is it's going to affect the y values. And so it's going to be increasing further and further at a quick rate. And so that means we're going to have y values then which are found between 1 and infinity. So if we consider the graph of an exponential function, what it's going to look like is it's going to look something like this, where we've got on the left-hand side, where we've got values of x which are less than 0. We can see that it's quite small and it's below y equals 1. On the other side, where we've got x values which are greater than 0, we can see it's increasing quite quickly here. And this is why it's called exponential, because it's increasing at an ever-increasing rate the more further along we go to the positive of the x-axis.